Have you ever wondered about the simple magic of a thermos flask? You pour steaming hot chocolate into it on a cold winter morning. Hours later, you open it, and steam still rises. The chocolate is perfectly hot. Then, on a blazing summer day, you fill that same thermos with ice-cold lemonade. Hours later, under the hot sun, you take a sip. It's still refreshingly cold. How does it do that? How does this one container seem to know whether to keep things hot or to keep them cold? The answer isn't magic. It's brilliant science and engineering designed to fight a powerful, invisible enemy. That enemy is called heat transfer. In the world of physics, heat is simply energy. And this energy is always on the move. Heat energy has one simple rule it always follows. It moves from a hotter place to a cooler place, always. So the heat from your hot chocolate is desperately trying to escape into the cooler air around it. And the heat from the summer air is desperately trying to invade your cold lemonade. The challenge for a thermos is to build a wall that stops this movement. To understand how it works, we need to know the three ways heat travels. The first is called conduction. Imagine you touch a hot pan on the stove. The heat travels directly through the metal handle to your hand. That's conduction. Heat travels easily through solid materials, with atoms and molecules passing the energy along like a game of telephone. So how does a thermos stop conduction? It uses a clever trick. A thermos is actually a bottle inside another bottle. If you could see a cutaway view, you'd notice there's a gap between the inner wall holding your drink and the outer wall you hold in your hand. But it's not just any gap. The engineers have pumped almost all of the air out of this space. This creates a vacuum. A vacuum is an area with almost no matter, no atoms, no molecules. Without a material to travel through, the heat has no bridge to cross. Conduction is almost completely stopped. The heat from your drink can't touch the outside world. Convection. Convection is heat transfer through the movement of liquids and gases. Think of boiling water in a pot. The hot water at the bottom rises, and the cooler water at the top sinks to take its place. This creates a current, a flow that carries heat energy with it. This same thing happens with air. Hot air rises. Inside a normal bottle, the air above your hot drink would warm up, rise, and transfer heat to the lid. The thermos defeats this in two ways. First, that amazing vacuum between the walls comes to the rescue again. With no air between the inner and outer bottle, there's nothing to create a convection current. Second, a thermos has a tightly sealed lid. This stops air or steam from escaping, which would carry a huge amount of heat away with it. So we've blocked conduction and convection, but there's a third sneaky way that heat travels. It's called thermal radiation. You can feel thermal radiation when you stand near a campfire. You don't have to touch the fire or be in the hot smoke to feel its warmth. Heat is traveling towards you as invisible waves, kind of like light waves. This is infrared radiation. Unlike conduction and convection, radiation doesn't need any matter to travel through. It can travel perfectly through the vacuum of space. It's how the sun's warmth reaches Earth. This means radiation can jump right across the vacuum gap in our thermos. So how do we stop it? Here comes the final piece of genius engineering. The inner bottle is coated with a shiny mirror-like layer. Just like a mirror reflects the light you see, this special coating reflects the invisible heat waves of thermal radiation. If you have a hot drink, the heat waves trying to escape are reflected back into the drink. If you have a cold drink, any heat waves from the outside that manage to get in are reflected away, keeping your drink cool. So a thermos isn't doing one thing. It's a fortress with 3 layers of defense. Vacuum stops conduction and convection. The tight lid stops convection. And the silver coating stops radiation. It doesn't know if the drink is hot or cold. It just knows how to stop heat from moving, period. It builds an incredibly effective wall to prevent heat from getting out or from getting in. The design is so simple, yet it's a perfect example of how engineers use their understanding of science to solve an everyday problem. They identified the 3 ways that heat moves and systematically designed a solution to defeat each one. So the next time you enjoy a drink from a thermos, remember the invisible science you're holding in your hands. A triple defense against the unstoppable flow of energy.